Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. My name is Uzair Muhammad and my partner is Umarun and Taufik. So our group present about the stage gas liquid separation process. First, what is gas adsorption? Gas adsorption is a unit operation used in the chemical industry to separate gas by washing or scrubbing a gas mixture with suitable liquid. And gas purification example is removal of air pollution from exhaust gas or contaminant from gases that will filter process. And product recovery is production of solution of gases of various purpose. And the type of absorber is PET column, lead column, spray column, bubble column, and another. So different between single stage and multiple stage separation is single stage is if two phases gas liquid are mixed together in a vessel then sprayed. While for the multiple stage is a phase that contact or mix in one stage, separate and then contact mix again in another stage. So our group recover about the single stage equilibrium contact for gas liquid system, which two different phases contact with each other and equilibrate intermediate mixing occur. Total mass balance, that's total mass balance for this single stage equilibrium. And these are three species present in the streams. And this component A is the only species diffusing between the gas liquid phases. Component B is in the air and C is in the water. And also assuming that water does not vaporize into air and air is insoluble in the water phases. Mass balance for A. So for the okay, so these are our examples. A gas mixture at 1 atm pressure, a solute containing A and CO2 is contact with a single stage mixer continuous with pure water at 293 Kelvin. The two exit gas and liquid stream reach equilibrium. The inlet gas flow rate is 100 kg/mol per hour with mole fraction of CO2 of YA2 0.2. The liquid flow rate entering 300 kmol water per hour. To calculate the given in the example is about this L0 equal to 300 kilomole per hour, and this V2 equal to 100 kilomole per hour. So we want to know about the V1, how much, and L1 equal to what. So the solution is we want to V prime is inert gas. We want to know we assume that V2 before that L0 is equal to L prime, which the inert water flow for 300 kg/mol per hour, and when we get the inert gas, we enter into the formula, this formula, and we make the another equation that for Henry law's constant to make the simultaneous equation. take from the A3 graph table, which 293.2 can be CO2 0.142. And then we get the second equation. So substitute YA1 into the YA1 lab, and so we get a single SA, SA1, and that get the SA1 equal to 1.41. And then we calculate the N1 by using the formula 10.3-9 So we get the L1 and we get V1. Okay, next my friend will cover.
I will present about the current industry practice. Okay, this is one of process that we choose, which is the hydrogenation process. Hydrogenation process is about adding of hydrogen atom to unsaturated hydrocarbon in the presence of catalyst to make it saturated. It consists of three-phase system, which is hydrogen gas, liquid oil, and solid catalyst. For this process, the temperature needed is around 120 Celsius to 220 Celsius max. And the catalyst used in this process is, for example, like small vehicle, light supported by organic oxide, usually silica or alumini, nickel, palladium, or platinum. Okay, this is the example of mechanism. This shows the alkene to alkene. Okay, example of hydrogenation process in industry is we choose a petrochemical process, which is the process of convert alkene and aromatic into saturated alkene, which is paraffin and alkene to naphthalene. Example is like xylitol and polyol is produced by hydrogenation of sugar xylose and aldehyde. The application in food is like processing of vegetable oil, fats, and it's convert unsaturated fatty acid to saturated one. Okay, the chemical process of xylitol. Xylitol are chemically produced from hemicellulose via acid hydrolysis. The composition are xylose, arabinose, and mannose, agaricose, and glucose. Okay, it present of nickel at 135 degrees Celsius and required 40 psi for 2.5 hours. For the process, it results around that's the percentage of the hydrogenation. And xylitol can be separated from the other sugar alcohol mixture by crystallization. Okay, this is the process of vegetable oil. Start from oil seed, then followed by crushing, refining, hydrogenation, filtration, bleaching or deodorization, packaging, then lastly product, which is vegetable oil. Okay, for the margarine production, margarine vegetable oil are commonly referred as polyunsaturated, and it usually added in this way to make them solid or semi-solid. Vegetable oil can be converted from liquid to solid by hydrogenation reaction. Okay, the effect of the current industrial practice in terms of safety, which is it exposed to hazardous substance, for example like sodium metallate that can cause burn on the skin and lung tissues if we inhale it. For example, another example is inhalation of hexane used for extraction. Okay, in terms of health, for the production of trans fatty acid, it it can cause allergies, and it can increase level of harmful cholesterol in our body and decrease the good cholesterol, and it can affect our heart, because we can get heart disease, and it could affect a child, which is development and growth. Okay, this picture just to explain the good cholesterol and bad cholesterol. Okay, in terms of legal, currently we don't have regulation regarding the content of trans fat in food production or requiring their labeling. So we suggest that the product should contain, in the labeling, they should put partially hydrogenated oil, because it's not good for our body. Okay, this is an example of product labeling, which they show partially hydrogenated vegetable oil. Okay, that's all. Thank you.